So I'm gonna go through the ones on the board. If we need to add any more, that's fine. Okay. So let's go through these. Oh, my first hour was playing Pictionary at the board, so the markers are really weird. Maybe another day. What's up? What do you need? Hi.
What's up? What do you need? Hi.
They're trying.
Oh,
I didn't know why my marker was so weird.
it's still pretty thick.
Oh,
Well,
no, right. No. Okay. All right, guys. So this takes us back to last chapter. Remember, way back, not even last chapter, earlier in chapter 2. We want to solve this for x. When we are speaking exponential, we want to switch it back to log. And base e is that ln. So we're going to switch this to ln. It's technically base e, but you don't have to write that, of 280 is going to equal x. So in order to figure out what x is, you're just doing ln of 280. And that's that converting back and forth between the base e or like e with the exponent and then ln and logarithms. So that's not a bad thing for us to review, given that, someone erased my exams over there. It's on the back of their work or their shirt now. But like November 3rd is like our semester exams for this, and so this would be something, kind of bring those back up again.
Wait, November 3rd.
November 3rd. You thought you were out of here sooner than that? Ouch.
Dang.
All right.
yeah, wow.
Well, let's
Nothing against you.
Right,
just,
right. I didn't
just
take-
calculus.
I didn't take it personally. It's okay.
It's allowed. Yeah. Man,
It's not this teacher.
All right.
it's not agreement.
Okay. So guys, that looks a little weird, but it's the same idea here. So we want to get rid of, so there's a square root, but there's also a third power. So I'd probably suggest trying to get rid of the third power first. So I would then take like the cube root of each side. Oh, I don't know why I just did that. So the cube root of each side would cancel this out. So I'll be left with the square root of 2t plus 5. And then the cube root of 27 is actually just 3. So I got rid of that third power first. So there was a third power, and so I took the cube root. Now I do that. I'm going to, that should be 2t plus 5. I realize my thing looks like a plus and a t at the same time. So now I'm going to square each of these to get rid of the square root. So it's 2t plus 5 equals 9. And now I can solve that.
Those kind of basic things like
Yeah. Talented. All right, yes.
Can you actually do 2?
2 as well.
Yeah.
Yes. 2. All right, that's a good 2. Oh, this, yeah, we had one kind of like this in our homework. Our homework, our notes. That's what we had.
I'm just saying this.
No, it's okay. I'm okay with being corrected. Yes. She did it nicely. It wasn't like she was like moron.
That's what she said. She whispered in it.
Yeah,
I'm
stupid. All right, so we can get rid of that, the number on the bottom, because 2/5 of 5 is just 2. So I get y to the second equals 16 to the 5th power, which is a big number. Whatever that is. I don't know. Yeah, obviously, 6. So some big number. And then I can take and then square root of that number, and that's where I can get it. So I like doing it in the 2 steps like that. I know some of you guys found other ways to go about it. However you undo what's happening. All right, so let's go to number 5. All right, so F, so they tell us that f of x is 5x plus 2, g of x is x squared, and h of x is 1 over x. They want us to do g of f and then h of f. Now, if it helps you guys to think of it this way, that's fine. What that means is I'm putting f into g. So this is going in there. So where the x shows up, that x leaves and this jumps in. So it's 5x plus 2, and then it's going to be squared. But again, don't kill puppies. We want to write this twice instead. And then we have to FOIL. And I saw a lot of mistakes with FOIL. So 5x times 5x, Tara, is, yeah. Yeah, so silly multiplication mistakes. 5x times 2 is 10x, 10x, and then 2 times 2 is 4, and then we can combine those. So this one just ends up being kind of a doable FOIL problem, but easy to make lots of mistakes on it. And then letter C says h of f. So again, in this case, the f is going into the h. So this is going in here. And so that's just going on the bottom of the fraction. I don't think there's anything else we had to do. It just goes in there. Oh, you guys didn't ask about D, never mind. Or you didn't ask about C. You said, does G of H equal H of G? So, if I put that in there and they put, so let's check that. So like, I did the wrong one, I did C. So, okay, so if I put G into H, so this goes in here. It's 1 over x squared. But this going in there is 1 over x squared. Kind of looks like they do, right? Because 1 squared is 1. X squared is just x squared, right? So is it yes? Should be yes, right? Yeah, okay. I was nervous. So they both, those would then be, yeah, no, they equal each other, so they're the same. Kind of a strange, that doesn't happen very often, I guess. All right, number 7, they want us to find the inverse. Oops, let's start with this. All right, so our first step is to put a y where the f of x is, and then flip them. So we're going to flip where the x and y is. So, oh well. So this is what my new one looks like, and now I have to solve this. So I'm going to start off by dividing or multiplying by 7 because that's being divided by 7. So I get 7x equals y minus 5, and then again I'm just solving for y. So this would be considered the inverse. So just being able to rewrite that. Number 8, they want us to prove their inverses, and so that's where we check, does f of g of x equal x? So does everything else cancel out of the problem except for x? So we basically, in number 8, are checking, well, they use g and h, of course. So I'm checking, does this equal x is my question, or basically trying to prove that. So So I have to basically put this in. So this is going to go in here. So cube root
Hold on a sec.
He said he left his water.
Oh, okay. Hold on a second. So I'll just wait.
I don't get it anymore. I get it.
Okay, no, it's okay. These two cancel, and so the cube root of x to the third is just x. They showed a lot more steps for it. You don't need number 9. Or
No,
do they?
and can I go with that?
Yeah. Check out dash.
Don't leave your water bottle in there.
Alright, are you guys okay on 9? You're switching to x and y. Alright. So, our notes for today are super short, like shortest notes ever, I promise.
They better. Hey, Maddie. So this one's not gonna be here for anymore. We have to remember. That's true. I don't even need this credit. I can graduate.
I don't think I.
So, I'm just stopping you from graduating in English credit.
Oh, I have.
I have my senior conference yesterday. She's like, oh, you already. You need 28 credits to graduate. You have like 30.
You're like,
It's like,
see
okay.
ya, like a
I'm
peace
like,
out.
okay,
No, you don't want to grow up early, just stay.
I am not graduating early. I don't want to miss.
No, there's too many good things that happen.
I'll graduate. I'm good. Like, I'll graduate.
Yeah, one of our friends, their son is like a baseball, likes baseball a ton, and they're like, oh, he should try to graduate early, and we're like, then you wouldn't be able to play baseball. You know, like I mean, like there's so much in high school. Like I don't know why people are in such a hurry to get out of
Just
baseball.
take fun classes.
Yeah, just
That's
like
what I
yeah, like go take like a woods class or whatever. Like, take something that. Okay.
Do you guys
The week of the 18th, we have a whole week. Like a real whole
I
week.
don't know if I took a question.
Alright. How many of you juniors are taking the PSAT? Or a bunch of you? Okay. So,
I never took it. So.
Neither did I.
And I got it in college.
How do you take it?
I didn't take it, and I got it in college, so I'm third.
It's supposed to be
Good questions.
yeah, I feel like I read that every day in announcements.
Yeah, I only take science and I am taking the SAT.
Okay. So, so that day, well, it is kind of a weird day anyway. It's like one of these days where we have really short classes in the morning. So we'll probably just have like a mini lunch or like a review day or something. Okay, right. Yeah, there's a chunk of you.
We're
So that's
having a
fine.
review?
No, next week Wednesday.
Can we have a review?
No, we're doing really short notes. Okay. Okay, guys. So, in our warm-up question here, they want us to solve these equations, and these require, again, going back a little bit to Algebra 2. Again, though, with the warm-ups, understand that I don't expect that you remember everything that you've ever learned, and so that's why we warm up with these and kind of see what you guys remember and what you don't. So you should be able to solve these problems, but if you don't remember, that's okay. I'll give you a clue on this second one. I would highly suggest factoring first. So factor, and it's not a terrible factoring problem, like once you get into it, but I'll leave you a second to try it, and then we'll talk about it as a group. What's up?
Oh yeah, and close to the time. You were, he told me he was going to go on this week, but I forgot what it was. I know Blake wanted, do you know if he still wants to go to Blake?
All right, do you guys remember how to do these?
No.
No? Anyone? Yes? Okay, thank you. All right, so, okay guys. So, the first one they want us to solve, and you don't need to factor already because they actually already factored for you. Now, actually, I saw real quick, Caitlin actually did factor this one more time, and that actually is going to be helpful. So, like, I'll explain you. So, hang on a second. You don't have to do that, but I'll show you guys why that's good. We can use something called the zero product property here that says that these two, or like either of these, if they're multiplied together, one or both of them should be 0, right? Because if this equals 0, and we're multiplying two things together, one of those sets of parentheses has to be 0. And again, I'll get back to what you did in a second. So we basically just set up a couple of equations here and say what would make this equal 0, or what would make this equal 0. Now Caitlin has a third one, so she has this one split into two, and that will work just fine in a second here. So the reason now I can solve these, I move this 9 over, and I get x squared equals 9. So then when I go to take the square root, what do I get? 3. And? -3. So you would have gotten them both because you factored it already. So this is both positive and -3 here. And then this one over here is kind of a little bit, you know, not a terrible equation to solve, but not exactly the prettiest thing here, -3/2. So these would be the two answers that would make this equation equal 0. That's called the zero product property, that two things multiplied together need to equal 0, one or both of them has to be 0. Pretty logical. Now in letter B it equals 0, but it's not factored for us. So that means we have to factor first. However, we probably have like a 2-step factoring we have to do first. What was your very first step in factoring here? Take an x out, because if you look, they all have x's. So let's pull that out first of all. So I'm going to factor that out of all 3 terms. And this is going to hopefully look better to you and not worse. Hopefully you don't look at that and be like, I have no idea what to do now. What's inside the middle there is that easy type of factoring. Like I think most of you guys liked it, where you had to multiply to get this number, but add to get this one. Hopefully that sounds familiar to you. So what's our numbers? To get -24 when I multiply, but add to get +2. Yeah, +6, -4. The signs are important because we want that 2 to be positive. If you have those signs flipped, that 2 would be negative when I multiply them. Now, just like we did in the first question, this is just zero product property. So how many answers am I going to have? We're actually going to have 3. We have, this is going to be a 0, this is going to be a 0, but x could also be 0. If I had 0 to begin with as my answer, that's one of our answers, 0 makes sense because all of those would be 0. So don't forget about kind of that obvious answer there. That's an easy one to miss out on. And then these are pretty easy equations to solve. X plus 6 equals 0, so that means x could be -6, or x could be +4. And so if you don't have to show each of those equations written out, I'm okay with that. So, kind of shook the rust off there if those were a little bit rusty. Rusties. All right, so, yeah, jokes. All right, so the next problem, or the next types of problems what we're going to do today is almost everything we're going to do today has to do with our warm-up questions. However, they're going to look like just slightly different. They do this thing called chunking, and basically what it means is this looks a lot like, this first example looks a lot like the second warm-up question, I think, but it's not exactly. So it like requires like a little bit of outside the box thinking, and sometimes it requires that we actually substitute something else in place as a chunk. Like we say that this is going to be what my x is in this case. So it's using factoring. Oops, I can write, and my board can listen to me. but also using like substitution sometimes. So I'm going to substitute like a stand-in. And I'll show you guys what I mean by the chunk, why they call it chunking. I probably don't use that word very often. This book does, so we'll use it. Bless you. So, this first problem here, to me, looks a lot like, I'm going to write it over here. Do you guys agree that it looks a lot like this? Yeah. So it's x to the fourth, but we only know rules for x squared. Like when I was teaching you guys this in algebra, I never said, let's throw x to the fourth in there. That would have been cruel. However, you guys are now smarter and more mature and able to handle tougher things. So we're going to factor this like we would have factored this. However, we just have to use a little bit more reasoning as we go with this. So rather than starting with x and x, what do you think we're going to start with? X squared, because there's an x squared in this problem, and it's x to the fourth. That makes sense? They're both, like, right? Because x squared times x squared would give me x to the fourth, and then that middle term, that's where the x squared comes from. What's the other half of this? What's the other rule that we did up here? What are we, how do we figure out this? Yeah, multiply to get 12, add to get negative 7. Negative 3, negative 4. Bless you. So this now looks a lot like, and if you're like, I doubt that actually worked, you could FOIL and check if you're a doubter. But now at this point, I should be able to solve these. Now you could factor the second one a little further if you wanted to, but hopefully we're good enough at solving that you know the square root has 2 answers. So this one actually is going to have 4 answers. Now every once in a while there might be an imaginary number that might pop in there. We haven't really talked about that much yet. They only want real solutions, so they don't want the imaginary ones. And if you're like, I don't know what that is anyway, then just ignore it. That's okay. So we're going to solve each of these. So I'm actually going to start with the 4. The 4 is a little bit easier. So then we're going to take the square root. So x is going to end up being positive and negative 2, right? We get those 2 answers. So that's 2 of the answers that would make this problem work. Whereas this one, a little bit strange, but not like, it's not like it's not the correct answer. It just isn't a very nice number. So we're going to take the square root. Now square root of 3, crazy decimal. I don't need you to write out the crazy decimal. We're just going to write plus or minus the square root of 3. That's fine. Both answers, positive and negative, should work, so we're just going to include them both. So don't let a problem that has some bigger exponents scare you. But you still have to do a little bit of reasoning. You can't like do, like if you see an x to the 5th, like don't like automatically think, well, it's just 3 and 2. So like make sure you make sense of things. It should still like mathematically work. We don't get to like break rules here. All right, so this next one, kind of like crazy things going on. There's e's, there's exponents, it doesn't equal 0. So first thing I'm going to suggest you do in this case is I'd like it to equal 0 because I know how to factor things that equal 0. So I'm going to make that happen first. So I would prefer to keep this highest exponent positive. So I'm going to move everything over to the left if that's okay. So both of these are going to move over. So I have e to the 4x power minus 13e to the 2x plus 36. And that equals 0. I'm hoping you don't see this in like give up, because I'm hoping you see this and think it looks a lot like the one we just did. You got snacks for me? Are those all things I like?
I think so.
They have their healthy snack day. But like sometimes with healthy,
So full.
he ate all your snacks, sorry. But they like, with the healthy snacks, sometimes you're like, this looks like it's gonna taste good, and then it's like a chickpea or something, and I'm like disappointed, yeah. Like, I don't know. Okay. It has 3 terms, so I'm gonna still suggest maybe you try factoring with our 3 terms here. Any ideas on how you think this thing's gonna start? So what 2 things multiplied together could give me e to the 4x power? 2x, yeah, right, e to the 2x. If I had e to the 2x times e to the 2x, wouldn't that equal e to the 4x? Yeah, we just add those exponents, and like that middle term kind of gives that away as well. What do you think is going to happen in the second half of this? We have the 13 and the 36. What's our rule with this? Add to negative 13, multiply to a negative 36. Yeah, this doesn't need to be any harder because there's e's in the problem. What multiplies to positive 36 but adds to negative 13? Negative 9, negative 4. So again, don't make this like that you're doing all sorts of crazy things here. Now let's set up 2 equations. So e to the 2x equals 9, or sorry, minus 9 equals 0. E to the 2x minus 4 equals 0. And this is kind of why we did what we did yesterday. So like number 1, I think on your homework was solving a problem that had an e with an exponent that was a variable. What are we going to do next in this? We're going to do the log thing, but I would do something before I did that. Move that 9 over. So e to the 2x equals 9. And the same thing's going to happen over here. E to the 2x is going to equal 4. Now let's switch it back to logs. It's log base e, which is that ln. Ln of 9 is going to equal what? 2x. That's something we should be able to solve. You shouldn't have to look at that now and be like, I don't know what to do. Again, it should be something now we can solve that and divide it by 2. And that's going to give us our x value. And then same thing here. Just make sure you divide by 2 after you do the logarithm, so it's not like ln of 2 or ln of 9/2. So like, if again, use parentheses if you need to. I got like 1.1 here, and then and like 0.7. That sound right? What you guys got? Let's see what he's got over here. It's a little animal, guys. One has a hair on it, right? I think it's all hair. Alright. Alright. Any questions? Was that okay? Not too bad? Alright. No, we're not break. We'll finish. We're only at 34. I only have like 15 more minutes with you guys, so hang on. We only have 2 more examples. There's really only 2, I think, right? Yeah, for real. Okay. This is the chunking. So they want you to solve this using chunking. And so this one's going to be a little bit more like kind of a little bit out there, like what exactly are we doing here? So what the chunk is whether or not I can make something look, basically I want to see a repeat of something. So I want to see the same thing twice. So I would like to see the same expression multiple times in the same problem. Does anyone think they can make that happen here? I don't know how to like get you to realize what I'm trying to get at here. Yeah. Move that 5 over. Yep, so yeah, and I heard that, yep. So that's what I wanted to happen, so thank you for catching on to what I was trying to say. So if I move that 5 over, what I'm trying to get at is there's a chunk here that looks alike. M plus 5 shows up twice in this problem. So what I'm going to do is I'm going to rewrite this problem and kind of take that M plus 5 out of there and hopefully help you guys to see something. So I'm going to say, I'm going to pick a new variable. I'm going to say U equals M plus 5. So this is going to be my chunk. So I'm going to take the M plus 5 out of this problem and try to ignore it for a little bit. So what I'm going to do instead is I'm going to write this problem as U to the 4th equals U. So this is me trying to like figure out how to solve this instead of having to worry about solving this. So we're going to kind of come back to the M plus 5 a little bit later. So how would you, so try to ignore M plus 5 right now. How would you guys solve this? How would we solve something like this? Well, I'd like it to equal 0, right? So let's make that happen first. So move that U over. Oops. Okay. Now what can we do? By factoring. What can we factor out? Take out a U. Your U out. And then we can do our zero product property, where U could equal 0, or U to the 3rd minus 1 could equal 0. Well, obviously U equals 0 doesn't really do anything for us, so we'll go stop there for right now. This, when I move this 1 over, how do I solve that? Cube root. So U would equal 1. So we want to solve the original problem though. So what we're going to do now is now we have a couple values for U. I'm going to put those back into my chunk. So I'm going to substitute these back in and find out what M could be. So I kind of did this problem in 2 parts. I figured out like a different problem to solve, but now I got some information about that, so I'm going to solve that part. So I'm going to change colors here so you guys can see what I'm up to now. So now I'm still going back, and I said U is 0. That would allow me to figure out what M would be. What would M be then? -5. So there's one of my answers. But then U, I also figured out could be 1. So I put 1 in for U, and then I could solve that as well. So I found out M could be -4 and also -5. Now, if you're a total doubter and you're like, that seems like she just made that whole thing up, you could go ahead and solve, you know, like check this. So if I put -5 in, -5 plus 5 is 0, to the 4th power is just 0. Minus 5 is -5, well that equals -5. If I put -4 in, kind of same thing happens. -4 minus 5 is 1, or plus 5 to the 4th power is 1, minus 5 is a -4. So they both work. It just, breaking it into like a different type of problem, kind of making it the problem we want it to be. Now this only works if I can have a chunk. This doesn't work if I like have M plus 5 and then M plus 14. Like it just, they have to be alike. So I have to be able to substitute with just like the one value. There's gonna be one like this in your homework. So I suggest kind of trying to use this example. I believe it tells you to chunk. If not, try chunking if you get stuck. All right, this next one. Do you guys see a chunk? X plus 4. So there's our chunk. I'm going to use U again just because actually a bigger chunk? Log 7. Let's do that instead. So let's call u log 7 of x plus 4. Now right now that doesn't seem very helpful. Like you're like, I don't know anything about log of 7 plus 4, but we'll worry about that later. So let's call u that instead. So anytime I see that, I'm gonna write u. Had I walked into my algebra 2 class with that top line, they would have lost their minds. Had I walked into my algebra 2 with the second line, I would hope they would not have freaked out quite as much, right? Like the second one's doable. So let's factor that. Multiply to 15, add to -8. -5, -3. So again, solve them. Hopefully this one's not too bad here. Set them equal to 0, so you move those over. So u ends up being 5, u ends up being 3. But this is not our answer, because if that had been the question, that would have been a much easier question than this crazy logarithm one. So I have to put those in here. So I know that 5 could equal log base 7 of x plus 4, and 3 could equal log base 7 of x plus 4, which means 7 there. Again, we don't speak log, or we're not great at solving log. Let's switch that over. How do I rewrite this? 7 to the 5th power would equal x plus 4. You guys okay with that movement? Again, that's why we did that in that last test, convert back and forth. I guess maybe that's 2 tests ago now. I'll go so fast. And then 7 to the 3rd equals x plus 4. There might be some large numbers here. And then we just move that 4 over. So is 7 to the 5th obnoxious? Or not too bad? Oh, it's not too bad. And then minus 4. So I get 16,803. And then 7 to the 4th, or 7 to the 3rd. Minus 4. Like I said, had you not realized that chunking was a thing, this problem would have looked like, you would have been like, what in the world is she doing to us? Like, that's terrible. But once you look at it as like a U, it literally looks a lot better. Okay? So, that's all we had to do for today. So, we have some time.